Thank you. So, Kevin Czaplicki, I created the Elm programming language. And normally when we talk about typed functional languages, it's often developers talking about, here are these features that can help us. But from the perspective of the decision makers who's going to be able to decide, can you actually do that at work? It's just indecipherable. They're talking nonsense to them. It's like, what? Can we build a type inference? I have a company to run here. And it's not just that it's nonsense, it's that other people are also talking nonsense. It's like, how can I make any sense out of what all these people are saying to me? So the goal of this talk is to try to look at typed functional languages from the perspective of someone who's thinking more about the business overall. So let's take an organizational view, and then let's look at some case studies to see how it affects the organization. And the way I'm approaching that is like, let's think of the engineering department as this box, and you take your money and you put it into the box, and then out of the box you get features. And what goes on there, that's what the nerds do. We don't, we just pay them. We yell at them. We make, get those features out. And then if we say, okay, well, there's more to it really, it's like, well, we have to pay for specific things. We need to recruit the people. We need to onboard them so they know how to deal with our technology. They need to actually develop it. And then ideally we can retain them so that we don't have to go do more recruiting and onboarding and incur those costs again. And then within development, there's all these costs of like, well, they're developing features, that's good. But then maybe they've done it in a way where they need to spend time optimizing, or they need to spend time doing bug fixes before they can work on the features, or they need to spend time writing the tests so that they don't have the bugs so that they can spend time working on the features. And so one thing we can think about here is efficiency, right? What percentage of money is actually going to doing features? And in an ideal world, the best talent in the world comes. They know all your technology. They just focus on development, and they're incredibly happy, and they stay forever. And then when it comes to the actual work they're doing, well, they're in an environment where their code's always as fast as possible and has no errors, and they just do features. So that's the ideal efficiency, but like just as a concept of thinking about what's going on in this department. And then also from a decision maker's perspective, there's lots of departments doing different things. They're all complicated in their own way. So the way I want to approach it from here is through case studies. So we're going to look at some companies that have successfully used type functional languages and try to get what organizational benefits they see from it. So the areas we'll be looking at are finance, business to business, and education. For one reason or another, type functional languages have done well in very different areas. The person teaching English language is not the same person on Wall Street. So we have 6 examples we'll look at, 2 in each area, and let's just get started with Jane Street Capital. So this is a quantitative trading firm, a market maker. So essentially what they're doing is there's a table in New York City where people sit around and they hand a piece of paper back and forth. They do that all day, every day. And at the end of the day, they go home. Job well done. Okay. And nobody exactly knows how much that piece of paper is worth at any given time. And so hopefully you go home and you didn't lose all your money. So at Jane Street, they traded $17 trillion worth of securities in 2020. So each day they sat at that table, and for each trading day, $67 billion worth of handing the paper back and forth occurred. And according to the Financial Times, they had $10 billion of trading revenues. So that ends up being $40 million of revenue per trading day. So they walk to the table, they go, hand it back and forth, hand it back and forth. The day is over, they have $40 million in their pocket that they didn't have in the morning. So it's quite an insane business. And yeah, I just want to emphasize, that's per trading day. Oh, it's Monday. Oh, it's Tuesday. So what's the cost of a bug in this setting? Like, how many errors do you want to be making per day? And how many errors are your competitors making? Like, this is a setting where, like, in a bad case, you could come away from the table with $0. But in the worst case, you're touching $67 billion of things. It's like the losses can be pretty tremendous if you have certain kinds of errors. And this company faces this cost structure like anybody else. And how they do it from a technical side is they have 30 million lines of OCaml and 500 programmers working with OCaml each day. And, you might be saying, OCaml, you can't do things with that. And it's, I'd say it sounds like you have a financial opportunity. You can go sit at the table with them and see if you have a clever idea. So I want to focus on how they get technical advantage, a recruiting advantage, and how they made a responsible transition to using OCaml. So for Jane Street in particular, when they're thinking about a language, there are many dimensions to evaluating languages, but ones that are very important to them is how fast is this language going to be? Am I going to be able to make decisions faster than my competitors? And how correct are my programs? Am I going to be making fewer errors than my competitors? And when you look at the big time languages, you could get extreme speed, but really the kind of error that I'm going to see there, I don't want to see when I'm sitting at that trading table. And so if we think of like what are the benefits of using the industry standard, it's like you get the same error rate as everyone else. So let's say I'm not Jane Street, I'm running a surfboard rental shop. Having the same error rate as everyone else in my team is fine because my business is really like I need surfboards, I need teachers, the real estate where I have my surfboards in one rotation to the beach, like all these things matter. And like, there's an error in the top. Okay, I'm not going to lose $40 million a day. It's not a big deal. And I have the same performance as everyone else. Fine, that seems good enough. And I have the same talent pool as everyone else. Great, like that's not my area of expertise. I'm a surf person, like, just give me someone. But from the perspective of Jane Street, this is horrible, right? Like, I'm going to go sit at that table, and I'm going to have an average rate of errors. And that means 50% of people are going to be trading better than me. And I'm going to have the average performance as everyone else. It's like, that's also horrible. Like, I don't want to be average here. And I'm going to have the same talent pool. That's no good. Like, I want talent that nobody else can get. I want people generating ideas that nobody else, none of the other people at the table have. So they ended up going into this area of typed functional languages where, it's for weirdos, it's strange, but when we look at the dimensions they care about, you're getting really high correctness and like quite good speed. And Elm compiles JavaScript, so it kind of has a barrier around how fast it can go, but in general, these languages should be between Java and C. And so they chose OCaml in particular. I said, look, those benefits aren't for us, but then how do you get OCaml programmers? So OCaml is taught at a handful of universities. That sounds bad. There's only a few. It turns out those universities are Harvard, Princeton, Cornell, and Brown, and a couple others. So it's like, okay, it's a handful, but it's like some of the most competitive universities in the United States. That's a great place to get talent from. And like, if your competitors can't get talent from there, sad for them. And OCaml tends to attract math people who are kind of on the pragmatic side. So it's not usually going to be someone who's majoring in economics to make money, but rather someone who's like interested in programming, interested in algorithms, interested in data structures, and really loves this way of thinking about programs. And so all these people are graduating and they're going out into the world. They're excited to get their first job. And they say, I really love working on OCaml. And then there's nothing. There's no jobs. There's no companies that do it. It's like, well, it's cool that you know that, but sorry. Well, okay, but there's Jane Street. And so for me, I was a student at Harvard and I graduated and I'm looking at the world and I'm like, no thought in my mind was like, I'm going to go to Wall Street. I'm going to live in New York City. But I was like, but if I could write OCaml, and it's like, they're just sending a piece of paper back and forth. It's like, and when I look around, it's like, there's nothing. That's the only option. And so from a talent perspective, they're able to get people who wouldn't even consider working in that industry if it weren't for the technical choice they're making. And then in terms of responsible transition, this is from a talk from their head of technology. He says, I was doing quantitative research on training strategies, but at some point I got sad about how slow Python was, so I switched to using OCaml because I learned it in grad school. And I think at this time, there weren't that many developers at the company. This is like 2003. A few years later, we made a more thoughtful choice about it. Our own internal infrastructure was mostly in VBA. He says it was really good. It was very well reviewed, but they knew they needed to do something better. And so after trying various things, they said, well, OCaml's working. Like, let's continue there. And in 2006, they had 10 people, and they had initial experience going well. They liked how they worked. They were easy to read. So they could say, if I have this strategy, it's actually translating into what we're doing at that table. And they decided to go with it. So when they had about 10 developers, they decided this is where we're headed. And I don't have like the quotes for you, but I imagine the technical advantage and the recruiting advantage were a big part of why they ended up making that decision. So when we come back to the cost structure, in terms of recruiting and onboarding, it's like, well, the only people who really are even interested or know about us are the people we want. And in terms of onboarding, they learned OCaml at Harvard and Princeton and Cornell and Brown. That's fine. And in terms of retention, if they say, I'm tired of this or that here, it's like, well, there's nowhere else to go to continue working in this way that you like. It's like, okay, I'm going to go down the street and make some amount of money over here, but like, yeah, but you're going to be writing C++. And it's like, okay, I'll stay. And then in terms of the technical advantage, like, these are languages where you can rule out certain kinds of bugs on like the languages itself can rule out certain kinds of errors. So you're getting quite an efficient organization because you made these like quite odd technical choices. So the other example we have in this area is Standard Chartered. This is a much more complicated bank. The only part that we're talking about that uses type functional languages is financial markets. And so my understanding about this is someone in London has some pounds, and they say, I want to buy, I've been looking at my spy satellites, and I've been looking at the data from the phones that tracks where locations are. And I think that this grocery store chain in the Midwest of the United States is going to have a bad currency report. And so I want to buy a feature of that. But I have pounds if they are in the interest rate or the exchange rate's going to change. And so we need to be able to figure out, if I buy that future, how much risk is happening for the company. And we then have to report that risk to some government organization. So they again have the same cost as anybody else, but in this case they have 6.5 million lines of Haskell and over 40 programmers working on it. And in terms of technical advantage, it's basically the same. You can get quite good performance with a high degree of certainty about how correct it is. So you're getting some benefits in bug fixes and text testing. And then in terms of recruiting advantage, it's similar but rich. So Haskell is more taught in British universities. Standard Chartered is a British bank chartered by the Crown in at least 50-something. And so they're from the University of UK and teach Haskell, which is like Oxford, Cambridge, University of Edinburgh, like fine places to recruit from. So they, unlike Jane Street, from people I talked to, it didn't seem like they were getting the same recruiting advantage, but that I think is mostly because they're not as public about what they're up to. So with Jane Street, they make a real effort and put real money into being known to the world as a place where OCaml happens. And Standard Chartered, I feel, is more private in a way that I feel is I would expect from a financial company, which is like, if we have something that's working, no one needs to know about that. That's our stuff. So it seems like they have more of an advantage than other two areas. But so so far we've kind of glossed over like, wait, why are we getting these benefits in bug fixes and testing? So I wanted to do a brief technical aside and talk about some logician sitting in some university who's saying, what's better than testing correctness? A mathematical proof of correctness. And he spends his career writing papers and writing books. And for one of those papers, he gets a Turing Award. And so typed functional languages are languages specifically designed to make these kinds of proofs really easy and beautiful. Because not all languages are equally easy to prove things about. So like JavaScript, for example, if you want a career in this area, that's where you go to suffer, but when you use these type of functional languages, your proofs come out great. It's really, you get some nice papers. So these people are creating all these ideas, and for any type of functional language, there's a core of ideas that you're going to see in all of them, and then a whole range of ideas that may or may not appear. And so when that comes to what do the languages look like that come out of this, you can think, well, kind of up there is OCaml that came out in 1985, and then a little bit above that, they're going to have a little bit more of the fancy stuff, is Haskell, which came out in 1990. And then at the other end, we have Elm, which was in 2012. So, with 20, almost 30 years of hindsight, you can decide more about what you want to include. And for me, the idea was like, I want only the greatest hits. I want only the stuff that like everyone agrees we're getting a real benefit here. And then the second thing was like, make it as friendly as possible so that people coming into it don't need to have a professor who's really deeply knowledgeable where they can pick it up. So what that looks like is when we run an algorithm that checks if your program's correct, we try to give you very helpful error messages. So this one is an example from this program, and it's just a program that gets random quotes about this and that. I'll try to get a good one to... Oh, that was a good one. Anyway, so in this program, if I go and make some erroneous change, it's going to say, hey, here's the specific line, should source be this other thing? And so this is happening if you have 30 million lines or 6.5 million lines. This same kind of thing is happening where you make a change, and then because we have these algorithms developed by these logicians, we can go and point to where these specific errors are going to occur. So coming back to our two finance examples, we can say, okay, can these efficiently be replicated outside of quantitative training? Not everyone is touching $67 billion every single day. And with these companies, if they run into some issue, they say, maybe our developers want different kind of tooling. And they come in at 9 a.m. and they say, please, can I have that? And you say, well, by 9:30, we're going to have like $1 million. So like we can do it then. And not everyone's in that situation. So our second area we're going to look at is the business to business users. So Corvus Insurance, they sell technical errors and omissions insurance. So that means TIC insurance safeguards against legal actions that could arise from alleged negligence, errors, or omissions in a tech product or service. And what is clever here is like they sell the insurance, but they also go analyze their system and try to look for vulnerabilities so they can make their rates, make it so they don't have to pay out as often because the people getting the insurance are in a better state. So they were acquired in 2023 for $435 million. And their setup is they have their own front end and an Elixir back end and around 50 engineers. And again, they have a cost structure. So in terms of technology, I interviewed one of their senior engineers that's been there for, I think, from near the beginning of the company. And I was just asking different things. So he said there's basically no bugs in the Elm code. He was saying that to the extent there are bugs, they happen on this border where sometimes you're going to get data that was supposed to be a certain way but actually isn't. And so, yeah, you can see that less spent on bug fixes. I asked them about testing. They said there's very little to test. We basically never think about it. And at some of these companies, you'll get this kind of answer where it's like, yeah, I guess we don't do that. But then when you say, well, and then it's like, oh, maybe we should. But then it's like, yeah, but we don't have any bugs. So it's like, so they're not doing very much testing there. Like it's not really coming up as an issue they need to work on. And then in terms of talent, only 10% come in knowing Elm. So the vast majority of people who have ever joined come in no experience. And on the one hand, he mentioned this automatically demonstrates a willingness to learn. So in contrast to, okay, this person accepted a job offer, that demonstrates that they're willing to be paid, they're willing to have these benefits, but those aren't necessarily predictive of what kind of engineering work they're going to do. And so he made a specific point to point this out about like how people can come in with a certain orientation just because they are willing to do this in their work. And then they're fully productive within 4 weeks. So they have like a onboarding, I think, hour thing. And then through pairing, they bring them up to speed. And they're saying, yeah, within 4 weeks, they're individual contributor like anybody else. And with the other technologies, there was sort of a different curve on what that looked like. And he also mentioned they have extremely good retention. When I asked about it, it seemed like he hadn't even really given it too much thought. It was like, oh yeah, like now that you mentioned it, yeah, we don't have that problem. And so he also mentioned some Elm devs end up working on the back end, and that can be disappointing. So yeah, then the errors end up being over there, and some people are like, so in this one, they're not trying to get the recruiting and onboarding benefit. They're saying we're basically going to be normal there. We're going to go to universities and get into internships, but we're going to get this retention benefit. And Vendr, our next one, is a SaaS broker. So if you're a company and you need a certain number of Slack licenses and a certain number of IDE licenses, and then you have to renew them, and you have to do negotiations with all the companies. They say, look, come to us, we'll cover that all for you, and if you need to lower the number, we'll lower them. So that's what they're up to. They got a 150 million Series B, I think last year, and their setup is Elm on the client and then TypeScript on their server. And they have about 25 engineers. And again, they have a cost structure. So in terms of technology, I talked with an engineer who'd been with the company since it was like 3 or 4 engineers. And he said, we don't do very much testing at all on our Elm code. And again, it was kind of like, I guess I should be embarrassed, but and so I said, okay, maybe that's bad. Like, what is your bugs like? And so he says, I don't recall very many bugs in our front end at all. The only thing that comes to mind is that we worked with TypeScript and GraphQL backend that should have been type safe, but often it's not unexpected values. So again, this border was where they were seeing most of the issues in terms of like unexpected errors that wouldn't have been checked by their compilers and static analysis tools. So yeah, you're saving on this bug fixing cost. And then in terms of talent, they have a very different strategy than Corvus. So they would hire front-end engineers who have Elm experience, and it went pretty well when they have great folks. So they were saving on the recruiting and onboarding because of people who came in already well. There were a lot of folks that joined Vendr to work on Elm, and I haven't heard of a single engineer that left because they wanted to work on anything else. So my impression was that the retention was quite good on a technical level. There are many reasons to change jobs, but for people here, it wasn't the technical. So back-end engineers, often, he mentioned this, didn't have Elm experience, and I mentioned this just because he said some interesting things. They were initially intimidated by the syntax, but quickly enjoyed working in our front end and run solid, easy to follow code despite being total beginners. He also said most of the time they would be comfortable doing things like this within a week of training, but then they do some pairing if it was more complicated. And then this kind of echoes in Jane Street. They have dedicated software engineers to work on OCaml, but their traders also write OCaml. So like you're seeing these systems that are designed for engineers, but they're used by people who don't have expertise and are able to come in and use them still. So when we look at these two together, they have different hiring strategies. So the Corvus strategy is hire without a background. Recruit like any other company, go to the certain university you go to, do internships, and then spend 4 weeks for the permanent efficiency gain during their employment. So they were saying even with interns, the first 4 weeks they're getting up to speed, and then the next 8 they're focusing on just being highly productive. And then they have the high retention. So essentially, you make this 4-week investment, and then you use it over the course of how long they stay, which is quite good, or like something that they never thought about before, which I think is good. The Vendr strategy is hire for an own background, pick the efficiency gain directly. And this sounds like it's like, oh, well, that's better, right? Well, there's a caveat, which is that some of the early engineers at this company had created very widely used packages and projects in Elm. So the company was immediately well known to everyone in the Elm community. So they became a hiring draw, and people wanted to work with those particular people. And so when you're comparing these two strategies, I would say what's nice about this one is it's stable and reproducible. Like you have a process that's able to bring people in, that's independent of anything else going on in the world. Then over here, it's more contingent, like what's happening with your talent, what's happening in the ecosystem, da, 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 da. And so if there are changes external to you, you may not have processes to deal with that as cleanly as in the Corvus strategy. So you're saving more, but like by having bigger margins, you have bigger risks. So the last case we're going to look at is the education one. So NoRedInk is reading and writing education software. They sell directly to school districts. So you can't buy it as a teacher, you can't buy it as an individual. It's just the school district says, this will help our kids learn reading and writing. And yeah, they got a 50 million Series B. So like a Monday at Jane Street. But for NoRedInk, it was really exciting. And so their front end is Elm, and the back end is Ruby with some Haskell. So again, you have a cost structure. And at this company, they started with a specific problem and a specific theory and kind of worked from there. So the problem was that for reading and writing software, there are some kind of complicated UI things that need to happen. We have this text, and we need to be able to highlight it. We need to be able to chunk the words. We need to be able to break the words if it's hyphenated. We need to be able to move our cursor around, get this rendering. And so rendering of these highlights. And so I talked to, again, one of the engineers who was with him. I think he was the 4th engineer at the company. And he was working on one of these things. He said, I built it in React. I wrote all my tests. The design totally flopped in the classroom test. So they had a product that was working. They were working on a new one. They bring it to the classroom. It doesn't work. So they start again. And he said this happened about 3 times where they kept iterating on the design and trying to get it to work. And he had experience with type functional languages separately. And at some point he was like, if we'd used Elm just on this project, it would have paid for itself already. Because he was having so much difficulty going back to this React code, redoing the design, fiddling with it, that each one was basically a full rewrite. So the theory that was operating at this company was the Python paradox. Now, I want to say, I'm not saying this is true. I'm saying that at this company, this is the theory they were operating under. So this is a idea from Paul Graham, who's the co-founder of Y Combinator. And in 2004, he wrote this little post that says people don't learn Python because it'll get them a job. They learn it because they generally like to program. And so if a company chooses to write its software in a comparatively esoteric language, they'll be able to hire better programmers. There are many factors that go into related to that. I think this is where I'm like not necessarily fully bought it. But this point, I think, is an example. Google, for example, when they advertise Java programming jobs, they also want Python experience. And so they're saying, look, we're not actually using the esoteric language, but that indicator of like, oh, this person is looking into technology outside of work, it's a legitimate interest of theirs, they're able to capture that signal without making a commitment to actually using that technology, which I think is like, in a way, the clever part of this Python paradox. But so yeah, so the theory is like, hey, can we save money on these two parts? Is the theory. So at NoRedInk, they had an existing, when they started out, it was JavaScript and Ruby. And so this engineer I was talking to said introducing Elm incrementally was critical. So it wasn't like, hey, we have this React app, it's our core product, let's rewrite it. Like, that's not sensible. That's not what people do. A full rewrite would have been too risky. So he was very specific of like, how can we choose a specific like element on a specific page to try and see if we're getting the game, and can I try that on another page? And so this is, in this particular one, he said it was less than a week from deciding to try it to having it in production. So the language works with existing JavaScript bundlers. If they are locking, they use Bugsnag. Whereas with Haskell or OCaml, like, just by the nature of being a backend language, like, these integrations can be more complicated. Because it's JavaScript, it's just kind of like, you don't run into as much there. And he really loves showing this graph. It's really small, but it's like, this is the production runtime exceptions in NoRedInk as of 2019, so 4 years after they introduced Elm. And on the left is JavaScript around 60,000. And I think this is, they looked at Bugsnag and said, like, list everything that's ever happened. And then on the right is Elm. And his joke is it's not at 0, it's actually at 1. So it was proof that the logging system actually was working. And apparently they tried to diagnose that bug. It seems like an extension was generating events that couldn't be produced by using the website as a human being, and that's what caused the issue. So yeah, at this particular company, they weren't dealing with bug fixes like they would have been, but they had quite a strong testing culture nonetheless. Because they came from JavaScript and Ruby, it was like really in the company culture to test a lot. In terms of talent, they specifically pursued notable Elm people, but they also hired from a 12-week Ruby bootcamp and then did onboarding and pairing. And so for those people, it was a similar onboarding to at Corvus, where in about 4 weeks, you become up to speed with Elm and productive as if you've known it before. So they're getting a recruiting benefit because they're bringing in people who are excited to work on Elm. And in the onboarding, some of them already know it, some of them are brand new. So some kind of benefit. And then the retention, a lot of people would stick around because they loved working on Elm, regardless of other details. So Brilliant is our last one. This is a funny one. So this is like math and science education. If you like watch YouTube videos that ever talk about physics, you probably see them advertise this. So in a lot of their lessons, they have these interactives where the person can move something around and it helps them learn. And so they have a bunch of these, and they're all pretty different character, pretty wild. And so those particular interactives are done in Elm. The rest of the site is other stuff, but those in particular are in Elm. And so I talked to the engineer who started at Brilliant specifically to work on those, and he told me how that happened. So his job was to build multiple small interactives all by himself, and he felt that like the bug load of maintaining those would pile up so quickly that he wouldn't be able to work on it once. So he said, having an entire class of bugs loaded in my Elm, I spent less time working on my previous 5 interactives and more time turning out the new ones. And so, yeah, basically usage grew because they found these interactives really helpful for having engaging, helpful content, learning content. And so at some point, our authors were non-engineers. right? So he was running it as an engineer, but they built a system so that their content authors could use this language to make them interactive. And from his perspective, he said, if the type's checked, we were confident that it wasn't going to have wacky runtime behavior. So it's not that someone who's an area expert in mechanical engineering can crash the website or introduce a security flaw. And so, yeah, so we can ship a lot. We can ship with a lot less QA across a broad surface area of experiences. So I bring this one up just because it's a weird one. So those are the case studies I was able to put together. That doesn't mean that's all that there are. But what does this mean for our decision makers? The concept of the talk is like, what are things we can take away here? So one is about developer efficiency. All the companies we looked at are saying, hey, we're not spending as much time testing, and not because we're incompetent, but because it's machine verified. Within these languages, there's a lot of things that instead of testing on a case-by-case basis, is this wrong? You can ask the compiler and it'll prove to you that it's not wrong. Remember the little logician who is writing all his papers. So yeah, they're also talking about spending less time on bug fixes, being able to understand the code better, and more time working on features. The other thing that we saw across a wide range was that they reported good retention. We saw different things depending on the particular hiring strategy, if they're making savings there or if they're having to make some investment to get people up to speed. And so I wanted to end with, if you're the decision maker, there are some things to know and some things to ask if you're considering these languages. So in terms of things to know, we saw again and again that hires don't need Elm experience. You can hire as you would otherwise, but expect to use onboarding parent for a few weeks to get them fully productive. Hiring for OCaml and Haskell is more complicated based on our particular case studies. The two we saw are taking people from universities where they learned those languages. I know of cases where people learn it at the company, but I don't have a case study that's like, here's what it looks like, here's how many weeks it takes. And yeah, in that, because these are back-end languages, more expertise and experiences need to get up here while you've been monitoring it before than if you're just sending it to JavaScript. The other thing is that recruiting benefits require communication. So if you are operating on the Python paradox and you say, I'm being weird, so then everyone's going to come to me. Well, what we saw with Corvus is they don't really talk about, like, I guess that most people who know Elm don't know about Corvus, even though by the numbers it's probably the most successful user, because they don't hire that way. They don't spend, like, to get that benefit, you need to be doing blogs and talks and internships and really engaging with that ecosystem to see that incoming talent. In terms of things to ask, how many developers do you have? So in our case studies, the companies that made transitions had fewer than 10 engineers at the time of that transition. So that's not to say it's impossible to do it. It's just to say that in our case studies, that's what we saw. So another is a trusted developer advocating for a typed functional language. So there are two scenarios here. Maybe one is you, the decision maker, is saying, I think we can get some business benefit out of these kinds of languages, but I don't have someone who I can trust to go for it. So in that case, you can say, when hiring for whatever is your existing technology, ask for experience with these others to try to build that talent and find that, like, trusted developer or trusted technical lead who can go forward with that idea. And then on the other hand, if you're skeptical of this, is a person bringing it to you a trusted, important technical leader? Like, is this someone who, when they tell you a deadline, they meet the deadline, or they give you accurate estimates, or like they make, like, you can rely on them to do what they say? And I think for a lot of smaller companies, when they have someone like that, they don't necessarily know that they could exist in a reality where they don't have someone like that. So one thing to think about is, like, keeping that person engaged and excited about their work and keeping them on for many years can be really valuable in its own right. Um, and then from there, is there a project that can serve as an experiment? And anyone who's transitioning was very diligent about proving to themselves from a business perspective that this was sensible. And so set a budget of time and money to invest in the experiment. If your particular organization's not getting the benefit, like don't do it. Like not like it is about like who's there, what's your recruiting pipeline. There's many details here. And then like any investment, like balance it against other things that are going on. Like if there's real trouble going on in some other area, like putting an emphasis on this may be a distraction. And like just be sensible about how you do this. And then just repeat this, right? If you have a successful experiment, are you comfortable having a bigger one and to see if it really works for you in practice? So that's a decision maker's guide to tech functional languages. Hopefully it's helpful. At the very least, I hope it starts a conversation in type functional language where we try to make ourselves understood by business people who just, can check out when we bring what we feel are legitimate technical improvements. So I'm Evan Czaplicki. Thank you very much.